Hi, in this video we're going to find the area of an isosceles triangle. Remember, an isosceles triangle is a triangle where two of the side lengths are the same. Now, when we have an isosceles triangle, a good strategy is to split it in half, because an isosceles triangle always has a line of symmetry. And can you see that this here is going to be the line of symmetry, and it cuts it into two exactly equal triangles. We say those triangles are congruent. So this triangle is going to be a right angle like that. And then because this 5 centimeters is cut in half, it's bisected, that's going to be half of it. So half of 5 centimeters is 2.5 centimeters. And the 52 degrees is also bisected, it's cut in half. Half of 52 degrees is 26 degrees. Now, it might help to draw this triangle out separately, like this. So we've got a right angle here, we've got the 26 degrees here, we've got the 2.5 centimeters here, and we're trying to find the area of this triangle. Now, do you remember the area formula for a triangle? We can use the area is half times base times by the height, where the height is always perpendicular to, it's at right angles to the base. So if we were to make this the base, then the perpendicular height would be this here. So you can see if you rotate that triangle, this could be horizontal, this would be vertical. They're at right angles to each other. So we've already got the 5. We need to find this purple length here, which is this length here, right? So let's give it a variable name, just x, and that's what we're trying to find, right? So remember how we use trigonometry? We label the sides relative to the angle of interest. The angle of interest is just a labelled angle that's not the right angle. So this is the angle of interest. And what are the sides of interest? Well, we have this side labelled with a length and this side labelled with a length. So let's look at this side first. This is next to this angle of interest. We say it's adjacent to, so we label it with an A. And this side here is opposite this angle of interest. We put O for opposite. And then we use our mnemonic SOHCAHTOA, we saw in previous videos, to work out which trigonometric ratio to use. Now, we're involving the O and the A, so it's this one, O and A, it's this tan one here. So remember, this is short for tan of the angle of interest, call it theta, is equal to the opposite divided by the adjacent. So this angle of interest is the theta, and now let's just substitute everything into this trigonometric formula. So we've got tan of the angle of interest is 26 degrees, is O, which is 2.5, over the A, which is x. And remember, if the variable's in the denominator, the quick way to allow it to escape that is to swap the things that you're dividing by in the division and the result of that division. So we're swapping the thing you're dividing by and the result of this division. I call it a swapsy trick. And then that gives you x is 2.5 divided by tan of 26. Now, if we do that on our calculator, 2.5 over tan of 26, or divided by tan of 26, gives you 5.12576. I'm just going to put lots of decimal places because I don't want to get any rounding errors. So we've got that. Let's put it in. This x here is 5.12576. And now we've got everything we need to find the area of this triangle. So the area is going to be half times the base, which is this yellow length of 5, times by the perpendicular height, which is the 5.12576. Let's put it now on our calculator. So we've got half times 5 times by, I can use the answer key to use that previous answer of 5.12, and that gives me 12 point, and how many decimal places? 1 decimal place, so 12.8, and it's an area, so it's going to be in centimetres squared. So it's 12.8 centimetres squared, and that is the final answer.